This is an experiment in order to demonstrate that carbon dioxide is given out during breathing. Over here in this experimental setup, two conical flasks are taken and a T-shaped tube is taken. Generally, what is done is, if you look into details, you'll be able to understand that a long glass tube is taken and that glass tube is bent in order to make L-shaped structures. The first L-shaped structure is put inside the conical flask A, and another, like, that is completely dipped inside the lime water, whereas another one tube is there which is also present, and this tube is halfway to the conical flask, not touching the water which is inside it, and and it is again forwarded to the next flask and is dipped completely inside the and is dipped like completely inside the water which is present in flask B. Again in flask B there is another half L-shaped tube which is placed. So we can understand that there are two types of tube which is used. The first type of tube which is used is L-shaped tube, right? And another second type of tube which is used is a tube which is this type tube. And ultimately a structure is formed which looks like a T-shaped structure, right? And all these are fitted inside the cork. Then after we will look into details what is filled inside both of the flask. Half of the flask is filled with lime water, and there is a place inside the tube where you can blow the air with the help of your mouth. Now what happens exactly in this experimental setup is we have a control over clip, or there is a control for letting the air which is blown to enter inside any of the flask A or flask B. We can control that depending on the clip C and clip D. If we open the clip C then and close the clip D, then the air which is blown in the pipe will move inside flask A, and if we do the reverse, that is we open the clip D and close the clip C, then the blown air will move inside the flask B, whereas it will not move inside flask A. I hope it is understood. You have to just close any of the sides in order to blow the air inside it. What exactly we are doing? We are once blocking this clip C. So if clip C is inserted or it is placed in the similar position, whereas clip D is removed, then the air which is blown will move inside this flask B. I hope it is easy for you to understand it now. In the first or at first what do we do is we close D and open C. If you close D, it means you are closing this part and you are opening this part. So this part is closed, whereas this part is open. It means clip C is not over there and you are blowing the air. So air is moving where? It is moving inside the flask A. And as because the air is moving inside flask A, we can expect some bubbling which is going to take place. But this bubbling is not causing the change in the color of lime water. The reason for that is the air which is blown, it is not blown inside the lime water, it is blown outside the lime water in the free space. That's why there is no color change which is observed. Later on, if we see the next setup, what is going to be done is the lime water. Now clip C is closed. So clip C is closed, whereas clip D is open. Clip D is open. Here it is open. So as the person is blowing the air, it is moving directly inside the lime water. As because the tube is opening inside the lime water, so lime water will be receiving the carbon dioxide directly inside it, and as a result of that we will see that lime water turns milky, showing the presence of carbon dioxide in the breath out air or in the process of expiration. So with this experimental setup we can very well understand that during the process of respiration, when we are expelling out a gas. That gas is carbon dioxide because it is turning the lime water milky when it is moving, when it is bubbled inside the beaker. Lime water turns milky at that process, and this process is giving us a clear indication that carbon dioxide is actually liberated out during the process of respiration. So this is the first demonstration which is there. Second demonstration is to demonstrate the action of diaphragm in the process of breathing. We already know that diaphragm is a kind of organ, or I should rather say it is a bend shaped structure which is capable of allowing the, it is a C shaped structure, I should rather say. And this structure is as such that it at times bends, gets curved, or another time, or in the normal position, it's just present in a normal straightened form. So we'll be studying that how is it actually helping in the process of breathing, how is it increasing the lung capacity and other, yes, how it is increasing the lung capacity. So at first what is done is we take a Y-shaped tube. You can see the tube, it is a Y-shaped tube. What does that mean? A tube which is this type, and to both the sides we will be using two balloons. So you attach two balloons at in this. Now after this we place this entire setup over here. We use a rubber cork. We will be just using a rubber cork over where we will be placing this. This is a rubber cork which is present, and we will be placing this entire thing inside a flask, and along with that we will be just attaching a rubber sheet at the base of that flask over where we have placed this structure. This structure looks like our lungs. Now see, um, first line, take a Y-shaped tube. The two small balloons over the two ends are both the tube has presence of these two balloons. Suspend the tube in bell jar by attachment with the cork. Then close the broader end of the bell jar by means of rubber sheet. It means the base. Rubber sheet is used at this base area. This one. The rubber sheet is like a diaphragm as because it is elastic, and the bell jar looks like a thoracic cavity. Now the Y-shaped tube is like trachea and bronchi. Yes, it is like trachea and bronchi, and the balloon are the two lungs. Pull the rubber sheet downwards. If we pull the rubber sheet downwards, then the balloons expand due to rushing of air into the lungs through the Y-shaped tube from the outside. Because air, if you apply some pressure from beneath, then definitely air will move inside. If air is moving inside, because of that, the bulging of the lungs will take place. The balloons will actually swell up, and this will cause the balloons to increase in their size. And later on, if we release the balloon or the rubber sheet, we will feel, not the balloons, I mean the rubber sheet. If we just leave this rubber sheet over here, if we leave the rubber sheet, it will just move back to its normal position. That is, it will just lie normally, and that will be the situation when it is in a normal condition. So at this place what will happen, the balloon will collapse due to the rushing out of the air. This happens due to difference in air pressure within the lungs and outside the lungs. So with this process, the diaphragm is sometimes increasing. When it is increasing the thoracic cavity, at that time we are, our lungs are getting completely filled with air. When it is just coming back to its normal position, then again it is expelling out all the extra air which is over there. So it is leading to expiration and inspiration, or helping the process of breathing. Next experiment which we discuss is this, to demonstrate that water is lost during breathing. What is done? Take a clean and cold sheet of slate or glass, gently breathe over it. Note that the surface becomes cloudy and there is presence of some droplets of water after some time. Even your mobile phone. There is tempered glass over your phone. If you just breathe over your phone, you will find some wet feeling. And if you keep on breathing that way in a close condition over your, in a very very close proximity to your phone, you will feel that there is some water droplets over it. So this shows that while we are expelling out carbon dioxide, during that time some amount of water is also released, or we can say that water vapor is present in the exhaled air. And it can be very well understood in this season, that is the winter season. You can do it very well, and you can get experience about how this process of breathing is actually occurring.